All right, so tonight we're going to talk about saving your assets and the Azure Resiliency planning. This has been a topic that I have worked with a few clients with to help them kind of gear up on basically dealing with the resiliency planning versus disaster recovery planning. And the biggest distinction here is that resiliency planning is about preparing for the various types of events that could lead up to disaster recovery. I'm trying to say with resiliency planning, you can minimize your disaster recovery needs, those efforts. So disaster recovery is about all the procedures to be executed after disastrous event has occurred, such as we're going to restore from backup. Whereas resiliency planning is making sure you are doing the backups and that they actually have data. So obviously, this can have a grievous effects on us. And when we try to figure out what we want to do about that, we want to consider was the cost of downtime, or if we're going to miss deadlines, how much trust of your customers can you afford to lose? May affect your order fulfillment, order processing, maybe it hurts customer support, even the ability to help support your customers. I even mentioned remote work. What if some of that outage is preventing you from logging into a system, gaining access to various pieces to help you control and mitigate various things. You might even have a regulatory compliance that is requiring certain levels of availability of your system, etc. So obviously, this can have big effects on your business and your company to stay afloat. So quick horror stories. And Salesforce went down in 2016. They went as a result of an outage that lasted over 24 hours and loss of data. And for Netflix, they had a gigantic loss, a lot of downtime, where they rebooted 218 of their production nodes and then found out that 22 of them failed to reboot because they were not doing reboots often for patching, etc., and making sure that they can come up. But we're also going to discuss some of those kind of conditions here in just a bit as well. Meta had an interesting outage in 2021, rather recently, that affected Instagram, WhatsApp, Facebook, and other hosted applications that they have. They had an issue with the BGP, so they needed to get in and deal with some routers, but it affected mainly their DNS servers, and it lasted 6 to 7 hours. And the biggest reason why is because them being extremely security conscious, they had their system on their DNS system on the same system as their physical security system. So when things went awry, they weren't even able to get into the doors. So supposedly somebody had to get pry doors off the hinges so that people can get in and reboot routers. So interesting kind of issue there. So what constitutes as a disaster? Well, obviously quite a bit, but I'm going to say that obviously it's going to be a condition when your system or business processes can be maybe not available at all, but even if it's a huge change of performance, something like if you're doing 1,000 invoices, your system is processing 1,000 invoices a minute, and all of a sudden it's down to 20, that could have disastrous impacts on your business and certainly SLA to your customers. So it doesn't have to be a full-blown regional outage. It could just be bad code. I mean, there's a lot of various things that could cause enough of a disastrous issue that it needs to be dealt with immediately. Resiliency is the ability of a system to gracefully handle and recover from failures, both inadvertent and malicious. I love it when Azure documentation provides the words better than I do. So, but that's essentially what this talk is about, is that preparation to minimize disaster recovery efforts and try to help mitigate needs as much as possible. Now, of course, we also want to have as little data loss as possible. Unfortunately, that is not the case. And as we get into distributed systems, distributed architecture, things like that, there's always an opportunity for data loss. And there's Sometimes there's ways to mitigate that, but it's extremely hard to have a zero potential. So it is definitely something that needs to be understood as well. Sometimes it could be where the data is in a virtual machine, it's in memory, and the VM for whatever reason dies off before it can persist that information to disk or to a database. Another issue that I had seen, and Randy is aware of this as well, where the I was working with AKS cluster and dealing with .NET Core 3.1, and there was a bug that they had causing a memory leak, and the pod would fill up with memory usage, and it was never being recollected by the GAC, so it just killed off the pod and then would respawn that way. And thankfully, they quickly fixed it by the next minor version, and we were able to continue on that project rather well. So what about the times when data storage is replicating and it fails, maybe because of a network issue, like what we call a network partition between two systems? There's other reasons and opportunities for data loss, such as maybe a network policy or a rule accidentally preventing access to a data store. Again, if you're not able to, in a timely manner, persist that information to disk or to database, etc., that could be a giant issue. Introduction of bug and code, etc., and even down to a regional outage. So one of the things that we talk about when we're trying to understand potentials of data loss and also the recovery time of a system is we get into conversations of RPO and RTO, recovery point objective and recovery time objective. The idea here is that with an event, when that event has occurred, there's time where that data may not have committed to either data store or disk and things like that. So depending on the event and depending on the condition of your architecture and things, you may have data loss. And so that is the amount of time and or transactions that are occurring just prior to that event, depending on your architecture and how you're set things up, depending on if it's between maybe like virtual machines to disk to databases, et cetera, even replications. That potential data loss could be milliseconds or it could be several minutes, just depends. Then we talk about recovery time objective, and this is how long it takes for us to get that system back to operational and what steps are done to help mitigate that and bring that back up, what actually constitutes as 100% functional or operational. And sometimes you're doing just emergency changes to make it even limping along versus completely down. Sometimes that RTO has to include restoring from a backup, just that you can have as much latest information as possible. When we get into SLO, which is service level objectives, we talk about the nines of availability. So you may have heard of 4 nines or 5 nines, things like that. With roughly 31.5 million seconds in a year, we can try to understand our level of availability. So what you'll see most often is when we talk about things like 4 nines for the 99.99%, that's 4 nines in with the 31.5 million seconds, it comes down in a year. It is just under 53 minutes of downtime. Now, that is not one issue, but it's all of the downtime summed up to that 53 minutes thereabouts. If you can have a system that is far more robust and you get up to 5 nines, then your minutes of downtime is only 5.5. So that is a goal. And you can tell some things are worse than others. But the biggest thing to understand here, and we're not going to get into how it's calculated, it could be another discussion itself. But when you working with an architecture, you need to take into consideration your applications, your servers, routers, the things that you're dependent on, from networking to even like Azure Front Door, Azure Virtual Machines, maybe Cosmos DB. They all have SLOs where they're going to say that they are up a certain percentage of that time. So, meaning that if they do not meet that agreement, that they can, there's different SLAs regarding that. So you calculate all this and you're kind of looking for that weakest link that can hurt that. Now, sometimes you're working on a server and you need to patch that server, and that could cause some downtime. Or hopefully you've got that server in a load balancer. You pull one of those servers out, you update the patching and security patching, etc., and you pop that back into the load balancer and go to the next one. Then the application itself or system itself is remaining up, and you do not have that kind of minutes of downtime in that case. But if not, you risk having many minutes of downtime. So we definitely want as many nines of availability as possible, but this is definitely something in those discussions when we are talking about architecture. So how should your applications behave when, not if, when the network fails? So there's a thing with networking that always it happens, and a lot of the times you don't even know it's happening because it can recover. Maybe that is within fractions of a second, or maybe a few seconds, or something like that, and it's taken essentially the routers are taking care of themselves, and maybe even repeating kind of conversations in there, the network conversations. So when we talk about consistency and availability, we start with understanding that our most probable cause is the network partition, that kind of that break in that conversation. I reference a game that I've played called Wordscapes. I use this as a great example. When my cell phone is not connected to a cell tower, maybe it's too far away, maybe there's an issue, or airplane mode, something like that, I could still play the game, and I can, still rack up points, etc. And what happens is that after when it connects to the network again, it will sync up with the server and says, "Here's my changes since," and let the main server know the points, etc. Now, what in this case, the application has favored availability. And when you're working with your applications in the architecture, you need to decide, are you going to favor availability, meaning that if there's some sort of a network break someplace between, could be between browser to API, maybe browser to a server, a hosting server, or what if it's from a server to a database, something to that effect. If there's that kind of a cut, how will it behave when that network partition occurs? Now, another example of this is in the other condition where we need to favor not availability, but we need to favor consistency. Something like, for example, online poker. If the server or part of the system is not available, then the application itself needs to not be available because it needs so much interaction, requires that kind of interaction, that it needs to have zero availability or decreased availability in favor of keeping the data consistent. Now, when we say consistent in the consistency, it's about keeping the data um, being the same or as consistent across multiple systems as possible. So if we have like replications, things like that, data replication, and we say it's going to be consistent, then each replica has the same data as the first one, as the primary. So when we look at this, it's called the CAP theorem, the consistency, availability, and partition. It was created by Eric Brewer. And the CAP theorem says that you can only have two out of the three, and you need to decide how it's going to behave. Now, generally, with the fact that network partitions occur, it's generally the availability versus consistency that you're making that decision of. All right, we're going to switch gears over to resilient hosting. You'll see that this is a giant collection of various categories. In resilient hosting, we'll start out with what's called active-active, and I will tell you up front, doing some research on this, some people call it active-active, some people call it hot-hot or hot-warm, things like that. I have seen descriptions that kind of contradict each other. So regardless, I want you to understand the concepts of it more than anything. With something like this called active-active, there is a primary system, or it could be a region, it could be another data center, something to that effect, where the each of the systems are getting sharing the load. They are actively sharing the load of the calls coming in. Whereas something like hot also could be known as active passive, just depends on the article that you're reading and such. This is where you have both system, the primary and the secondary, they are both up, they're both running, except only one of them is taking all of the workload. So say they're the one on the left, that's taking 100% of the load until there's a need to fail over. The secondary system or region is up and running. It is available to handle the request at a moment's notice. Obviously, this has the highest cost, but it is there for that reason to have at a moment's notice to take the calls, take that workload. Now, another one is when that secondary, it's called hot warm, then when the secondary system they're almost ready, meaning that there could be something like a virtual machine or some other type of service that is turned off, and it is not available to take calls until it is turned back on. So it is there and it is available, but it still takes an effort. Maybe that's scripted, maybe there's some automation there, or maybe it's a manual effort required to make it 100% available to start taking the workload. Now, the other one is hot cold, where that secondary may not have all the components. It could be such thing where you're definitely relying on a script of some sort, hopefully automated, where it will say on request or on trigger, it will create such as a virtual machine or some other service and fire that up. And obviously, that's going to take the highest amount of time before it to come up and take that workload. Now, the key points on those is as you're deciding this, and I want you to understand too, is that when you decide these kind of architecture, it's not all or nothing. It could just be based on the various applications that you're hosting, and you may have to decide one type of architecture versus another. What if one has a more criticality than the other? So you want to kind of compare those. So when we talk about that recovery time objective, that RTO, if I want to have as little RTO as possible, meaning that I want to have the ability to be up and running as quickly as possible, you would have something like that active-active where either it is already sharing the load and it simply scales up to take 100%, or it's available and it's just a matter of switching over the load balancer and it says all of the traffic now goes over to this other one. So that versus the hot cold where it's the highest RTO, meaning that if you have to wait for some other things to spin up, to be created, etc., then it's going to take the highest amount of time for that to come up and be online. Now, I say the highest RTO may have the lowest cost versus the lowest RTO is going to have the highest cost. So it's just going to have to be part of those discussions that when you're weighing something of a critical architecture for critical applications versus another. Something else to consider is that when it's time to fail over, so we have the concepts of failover and fail back. Now, when we talk about failover, it is obviously when we're talking the workloads of the primary systems or the primary area, etc., needs to fail over to the secondary. Again, this could be at different data centers. It could be different availability zones. This could be different Azure regions. It just depends on how you want to apply this. So this is essentially what we're talking about with failover when we're needing to rely on our secondary area. Now, failback is going to take some time, but this is essentially when now the primary area is back online and we need to shift some of the workload back over to there. This could be done because maybe that was where the better scale of the services was at, and where your secondary was just enough to limp along. And it just depends on the severity of the outage, depending on if it was just a service that was down or all the way out to a whole region that was down. A lot of decisions that can, need to be dealt with in that. But something that's interesting about this is that, well, with failover, that could be caused by Azure or you, depending on, like, if you're going to test something, or if you want to do like Azure Site Recovery, etc., and you want to fail some things over, you want to try things out. But a failover can also be caused when Azure has an issue with, say, as not a whole region is out, but what if it's, for example, a storage service is out? Maybe there's a, it's out for a few minutes or something like that, and they could initiate a failover. It could be at a service level or product offering level is where that could happen. But a failback may not be under your control. And what I mean by that is if Azure says this service is not available and now the primary is available, it's going to do what it can to resync some things that it is in control of, but it may bring back a primary area, a service, a product offering, or a region, depending on the outage. And it may be bringing that back online when your architecture is not prepared for that. So it's possible that your secondary has more of the latest, say, invoice processing type things, for example, that now the primary is not aware of. You're going to have to be responsible for making sure that the primary now has the updated information, that resyncing of things. Now, I do mention an Azure region, and I've mentioned the availability zones, but let's dive into what an actual Azure region is, what I call the anatomy of an Azure region. So looking at the US specifically, there are several Azure regions in the US. Now, I could mention all of them around the world. More to the point, though, is it's easily demonstrable right here, is that in each of these regions, there's data centers and availability zones, which I'll dive into in just a moment. But these also have paired regions. And the paired regions is definitely part of the discussion when we talk about resiliency and disaster recovery, and the availability as such, because they are paired by Azure, not by us. For some things, you do not get your choice of what other region you replicate data. Cosmos DB, for example, in Cosmos, you can add geo replication. You can replicate your data to pretty much any other region that you want to. But with Azure Storage, you do not get the option. With Azure Storage, if you elect for geo-replicated data, it's going to replicate that data to the paired region, not the region of your choice. So if, for example, we have a South Central Azure region, and we elect to do geo-replicated on the Azure Storage, it's going to replicate to the North Central over in Illinois, and that's going to be the secondary. Those are the paired regions. Now, I say primary, that's relative to what you consider the primary. If you create that storage account here in South Central and have geo replication enabled, then automatically the secondary is in Illinois. If, for example, there is an outage with either the storage service or a regional outage, then what happens is the secondary of that storage account becomes essentially the primary, is now what's serving the request. Thankfully, our applications do not have to adjust because Azure handles the DNS behind the scenes. So when a request is going into and looking for data that's in that storage account, it will actually get redirected to the secondary. And but would also, if you have the what's called the read accessible geo replication, then you're on a normal day, another application could read from your secondary, but not write to it. When there's a failover, that Azure storage of the secondary becomes and acts like a primary. Now it's write enabled. So when the failback occurs and your primary comes back online, then what I believe is done behind the scenes is it does sync the data across there, but it is very possible that this area is considered back online before that happens. I'm not going to say it's guaranteed either way. So your applications might need to be aware of that possibility when that occurs, or if and when it occurs. So there are paired regions, like I said, generally speaking, the paired regions stay within what's called a geopolitical boundary. So the US is a geopolitical boundary. The UK is a geopolitical boundary, right? It's got London and Cardiff are the two inside that one. Germany is to itself. Um, Generally, you do not have replication jumping over geopolitical boundaries. Brazil happens to be one of those that slightly breaks the rule for the moment. So I mentioned that North Central, well, relative to South Central, North Central is the secondary is the of that paired region. Now, obviously, if you create resources in North Central, then South Central is its paired region, so it's considered the secondary. That's relative to where you're putting your resources in initially. With Brazil, their secondary, their paired region is South Central. So it is kind of jumping over that geopolitical boundary. Now, South Central cannot replicate to Brazil, but Brazil can replicate over to South Central. That is getting ready to, if not already, stop because there is another region being built. I don't know if it's done just yet. So when that is back online, then the secondary will be another region, I believe, in Brazil or very close to it. So, all right, now when we look inside of a region, we have data centers. Now, I can tell you that I have no clue how many data centers are in an Azure region, and I'll never have access to that, and it doesn't matter. So, to the point, it could be 3 data centers, it could be 15. I don't know. Thankfully, we don't have to know. But inside of an Azure region, it is a collection of data centers. Now, obviously, a data center is going to be a building with all of our servers, right? All the servers and from disks to, yes, even spinny disks that are not they're not the solid state, but the regular hard drives that we're spinning over to other types of services being hosted inside those various data centers. Now, most, but not all, of the Azure regions have a thing called availability zones. An availability zone is a collection of data centers, but they are separated by a very key piece to help allow for, and this is why they're called availability zones, to keep with availability. They are each of them have distinct power, cooling, and network. So if, for example, availability zone 3 was to have an issue and it's not available, availability zone 1 and 2 would remain because, again, they have their independent power, cooling, and network separate. What's also really cool about this is that, again, they're inside one region, is that if you're going to have resources that are in one zone needing to communicate with another zone, there is a fiber connection between the availability zones. Now, edge router to edge router, you have no more than, and a guaranteed no more than 2 milliseconds of latency. That could be from availability zone 1 to 3, 1 to 2, 2 to 3, however. They are not laid out in any kind of physical formation, certainly not one that I can depict on the screen, but they are guaranteed with their fiber connections to have no more than 2 milliseconds of latency. So that's really cool. That's really awesome. Now, like I said, not all of the regions have availability zones. They are working on that. North Central, if I think North Central still has one, which but that's another key piece. They either have none or they have three. If you are familiar with AWS, yes, AWS can have anywhere from 2 availability zones up to 6, but they also don't have as many regions as Azure does, but they have more availability zones. So it's kind of pros and cons on that in that comparison. Also, something to know about is that the availability zone 1, 2, and 3, that is relative to an Azure subscription, meaning that if you have multiple Azure subscriptions and you create, for example, a virtual machine and you create them all in availability zone 1, there is guaranteed that they are spread across various availability zones. They differ per subscription. And they've done this so that if, for example, 1,000 people all put stuff in availability zone 1, it will not get overloaded. It will not, drain the capacity of that one while availability zone 3 is fine. It helps to spread that load of the resources being commissioned for that. So when we talk about resiliency, though, when we're going to create let's say a virtual machine, I'm just using that as a quick example. When we create a virtual machine in an availability zone, we need to make sure that that's resilient. So we're going to create another instance of a VM in a different availability zone, and then we'll use a load balancer to help spread that load so that if one was to go down, then you still have your application or your service still available um, while one has an issue and the other one can remain up. Now, does that have increased cost? Of course it does, but that's how you can keep some high availability with that. All right, so some considerations to when to thinking out your architecture is, and there's going to be quite of considerations and details that I'm going to jump into here in just a second. Starting with like even with your accounts, and I don't necessarily mean user accounts, but if you do have various Azure subscriptions and you need to have those where you can have ability to fail over, you might want to check your accounts such as your service principals, your managed identities, and things like that. Make sure that your network rules that you have in place allow for the different IP addresses that you've set up in your disaster recovery area, if you're going to use a different VNet or region, etc. Service level agreements, you definitely want to understand the ones of the products and services that you rely on, because that also helps affect the products and services that you offer. Also looking at the RPO and RTO, that recovery point objective and recovery time objective, that is going to be per database option, meaning like if you're going to do Azure, a database in Azure for MySQL or Azure SQL or Postgres or Cosmos, each of those are going to have and offer different RPO options on that, as well as per custom service. Are you going to do an Azure app service? Are you going to do an Azure container app? And understanding your cost of being down and unavailable while things are being worked on, etc. And you may even have data residency laws. This is why we're talking about that geopolitical boundary, where you've got to make sure that your data is not being replicated into another area where it's actually not allowed. Such, for example, data that originates in Germany has to remain in Germany. So when we talk about implementing resiliency, we're talking about storage replications. I mentioned that with the paired regions and making sure that that's well understood because of the capabilities of that option for failover, but also how it fails back. And with the RPO, that recovery point objective, which is that potential for data loss, that time period or transaction period, because even with the speed of light, it could jump across thousands of miles. You still have some latency as it's jumping across. For example, East US over to it's paired over at West US too, etc. And even with like Cosmos DB geo replication options, that you may be going to multiple regions and still going across many hundreds or many thousands of miles. And because of that time of latency, there's that potential for an outage and potential data loss. Network failover and latency options. If you're going to use like Azure Front Door and Azure Traffic Manager, both are layer 7 devices. Azure Global Load Balancer, layer 7 device, whereas Azure Load Balancer is a layer 4 device, and they operate different and have different options available to them. Azure Application Gateway is a regional option, but it also allows for a web application firewall, as does the Azure Front Door. Um, Network security groups. I definitely suggest you do not rely on specific IP addresses in your rules. If you have virtual machines, consider using application security groups. It is treated kind of as a grouping, but providing an alias instead of IP specific. Also, big key item on this one is it is actually possible to prevent your data replicating on an Azure storage account. It is quite possible for an Azure Network Security Group rule to prevent that. So what you do want to do is be sure to add a rule with the service tag for Microsoft.storage, I believe it is, to allow replication regardless of the other rules. Also, if you have network virtual appliance, such as if you can do a custom firewall like Palo Alto or a Fortinet, etc., then you're going to make sure that that is replicated in your secondaries, and also have whatever rules and configuration that you have applied that has also been copied over and applied into your secondary network virtual appliance there as well. Products like Azure Site Recovery offers plans that you can create. Those are not Azure plans, but what you create is what's called a plan. And it's about what kind of things are being handled, how they're handled, et cetera. And it's an orchestration tool. It provides orchestration, meaning that it can help with the priority of the resources to create in the event of disaster recovery. So I mentioned DB before as service. It doesn't help if you have an application that's popped up and is relying on a database, but the database isn't there yet or it's not alive yet. You can set that up with your orchestration so that it guarantees you that some of the foundational pieces are there first. Also recommend a playbook. So that you might even have a compliance or regulatory requirement says you need to have plans that are for your environment that you are going to not only present but adhere to. And the playbook versus a run book, the playbook is the kind of a collection of scenarios and it's the who to call, etc. Whereas a run book is going to be the actual step-by-step processes that get activated based on the scenarios in the playbook, etc. Definitely automate as much as possible. Look into Azure automation. That certainly helps with things like setting up a server and configuring it, etc. When you are recreating resources using something like infrastructure as code, ARM templates, Bicep, Pulumi, Terraform, etc., which I do highly recommend, be sure that your scripts are up to date so that you can recreate your environment as quickly as possible. Maybe look at automation for doing that. Maybe a script that kicks off Terraform, for example, or is it going to be an alert of some sort that's triggering it? Using Azure DevOps is another good way to script that or to launch scripts anyway. Something to be careful of, though, is that if you are failing over to another region, for example, if there is a regional outage, you're not the only one scrambling. So you also are going to have to recreate resources in your secondary, and it's first come, first serve. So while you're in that boat, everybody else is too. They're going to be scrambling. And I will tell you that one of the problems with, although it's going to be a higher cost, if you do not have your say your virtual machines, for example, if they're not up and running, then there's no guarantee that they will come back on because of that resource capacity. An Azure region that's serving a lot of people then and a lot of demand may not be prepared to handle a whole nother region outage and then everybody jumping over to it. So be very careful of that. And what I mean by that too is that if you have a VM that is deallocated or simply turned off, there's no guarantee that when you try to turn it back on that you're going to get actual the computational resource. Just because it's there in the Azure portal does not mean you actually get it unless it is up and running. Also, be sure to maintain your security and access to container registry, your images, etc., your backup vaults, your recovery vaults, etc. And I mentioned accounts on VMs. If you have custom accounts, maybe it's tied to some Active Directory that's in another VM or some other IDP. You want to make sure that those are available in your secondaries as well. Configuration information using Azure App Config has a option for geo-replicating, which you should definitely take a look at, and then have your sensitive information stored in an Azure Key Vault. Be sure that your Azure Key Vault is backed up and frequently, because an Azure Key Vault cannot geo-replicate. Although it is possible for you to move it to another subscription, for example, you cannot move an Azure Key Vault to another region. You cannot move it to another location. You have to do a backup and then restore for that. So you want to definitely check your keys, secrets, and certificates that are stored there. Make sure that they are backed up on a frequent basis. There we go. Okay. Azure Container Registry geo-replication option is available. Azure Kubernetes service. If you're using AKS, you may have to replicate that, and what kind of scripts would be needed to recreate that on a whole different region, and with all of its other dependencies that your applications and your systems may have. The same thing for Azure Container Apps. With virtual machines, your images, be sure to back up your images, such as if you have anything custom on there that you need, how fast would you be able to and easily be able to recreate that if needed? If it's gone away and it's required, how soon could you build that in a different region? Configuration, what I mentioned here is that if you're coming from an image, although the Azure VM will have a different name, the operating system level may actually have the same name. And if it's starting to put information into logging, would you actually know when you're trying to know if that's one system is up versus another, et cetera? To be sure to check your compliance and regulations requirements. If you're auditing, be sure that's part of your audits, et cetera. There's policies that you may be adhering to. You can also use things like Azure Policy to help maintain certain levels of resources in Azure. So if, for example, if you're in a production subscription, you've considered this system or your architecture is the production version versus a development one, you can have Azure policies that says that it is not possible to create something that is on a basic or a free tier because it won't have the same options available to it that you're going to require in production. You can also use Azure policies to help guarantee other things are in position. And if you create the policies after the fact, it will tell you which ones are non-compliant, and then you can go through there and fix up which items and resources that are not compliant. With your data, Azure SQL database has an active geo-replication option, as well as check its RPO options. Is same thing with Cosmos DB. Azure monitoring. Logging. So your logging is going to go to like log analytics and you're going to go to a single region. But then when you're starting to log to a secondary region and then fail back, you may have two locations to be looking for log information to verify some things. Also, metrics. This kind of goes down there with the baseline. Understand and be able to measure actively what your system is doing, your architecture is doing. How do you know if it's performing well? This is not just a looking for a performance thing, but understanding where you currently are. If it's doing, for example, processing 1,000 invoices a minute and then it drops to 20, are you measuring that? And along with alerting, how would you know? So with the metrics, you're able to compare. The metrics is the gathering of that information, where alerting is the comparison of that information to some conditional standard that you can say, well, we went from 1,000 to 20. That's definitely below some threshold. And then you need to do something about that. And along with alerting, you can do with action groups. The action groups is the who and how to notify based on those conditional events that have been fired off. Um, and Azure monitoring could be a whole talk in itself. There's so much capabilities to it, so it's definitely worth looking into it as well. Testing your plans. Now, it would be nice if everybody already had a plan, and I want to encourage you to do that, but I want to highly encourage you that after you get your plans in place, that you test them, because Delta Airlines had a fire in a data center in 2016, and it was discovered that 300 servers were not wired to backup power source. The impact itself, because of all that, cost them nearly $100 million in lost revenue. So performance matters for them and availability. So that is one of those things where they didn't, even on a wired connection, did not test it, did not check it, and challenge some assumptions on that. Here, there's a hospital, I believe it's over in the UK, that they're going to test their power generators that they've had for years. It's awesome, great, and notified some people there's going to be a disruption. Well, hours and hours had gone by, and the disruption was not noticed at all. So, when inquired, they realized that they could not continue testing because there was actually no fuel in their state-of-the-art emergency power generators. So it thankfully they found that out during a test versus when they were requiring it, but they should have tested it long before that. Planning. So when you are planning your resiliency and you're trying to develop this out as well, make sure that multiple teams are engaged. Even on that case, that was even the wiring, right? The electricians were there, or the fuel, and the procedural place. That team of such was not engaged well, right? So it depends on the various services and architecture that you have. You want to get as to who you want to get engaged on that. um, Make sure that all the members know the tools that are required for them to do their job, as well as, not just testing the plan, but also performing any of the disaster recovery efforts. Make sure that your action groups, that's the who and how to notify people, make sure that they're up to date. You may have a new employee, or maybe you let one go that, or change of position or whatever, and they need to be updated. Make sure that alerts are created to actually understand what's nominal, and how to detect when you actually have an issue. Consider, while you're testing things, consider, what if this outage is because of a security breach? How are you going to handle that? What about if it's a network outage and not a regional per se, but it's a network itself? Maybe it's on-prem. It has the issue and it's trying to replicate this things up to the cloud. Also, consider not even being able to access the Azure portal. That has happened, unfortunately. So I was on call that day when a certain event occurred, and even trying to log into Azure portal was almost impossible to even initiate some of the scripts. So there's going to be times when yeah, you're going to have to consider you can't even access the portal to kick off certain things. How would you do that? What would be your plans in that case? And I also mentioned a phased approach. You don't have to do everything at once. So nor in all in one meeting. That would take months anyway. So definitely get started. It's definitely worth the time doing it. Tools like Azure Chaos Studio is not available in all Azure regions yet, but it is definitely a great tool to check out. Now, one of the things to note, though, is it actually does real changes to the infrastructure. It is not simulated, meaning that if you would like to test that a virtual machine, um, is just not available on the network, it actually changes the flag in the FPGA that the network is running on, and that VM is no longer available on the network. So it will do real changes, not just simulated ones. So you get to do some really good tests at that level. Also consider Azure load testing to help generate traffic so that you don't have to test in production. Azure products evolve, so definitely want to stay apprised of the capabilities of Azure Site Recovery, Backup, Migrate, and Azure the Resource Mover. Code deployments. So I highly suggest that while you are deploying to your primary locations, sending to Azure App Services, your VMs, etc., that you're also going to the secondary locations as well, making sure and keeping them up to date. I'm from a previous company that I was working at, they in their OS and security patch routines, they would always go to the secondary regions and make sure that they are up to speed and up to patched up as well as their monthly processing. Challenge all assumptions. Knight Capital, they did a software update. What they actually did was reuse a feature flag, and they decided to deploy their code out to their 8 servers. The assumption was it got out to all 8. It did not. The update only happened on 7 of them. And because they reused a feature flag and it actually executed old code, within the first hour, their system had actually purchased over $7 billion of stock. Long story short, the company was later purchased with a loss of over $400 million in evaluation. So, yeah, challenge your assumptions on every level possible. Now things do evolve. The business changes, right? Your business requirements, right? The business in your company in the market, right? It's going to change. Therefore, your architecture is going to change. Therefore, your testing needs are going to change, along with your resiliency and DR plans that also need to change. So definitely want to make this not a one-off, but maybe it's a yearly plan check, if not maybe twice a year. Know your assumptions and challenge them as well. All the code is in a repo and the apps can be recreated at any time. Can you prove that? Have you tried that? The repo is globally accessible all the time. Well, that's a careful assumption. Um, uh, your DNS is safe and unable to be hacked. That's already been proven false. The scripts that built our infrastructure will always work again. No, they won't. Things change, including like, for example, virtual machines, even they evolve. So you're not going to be able to get a version 1 of some of the VM types. You're going to have to go to a version 4 or a 5, etc. It's cheaper to apologize to customers than to build and test your DR plans. That depends on your business, your industry, etc., and your agreement with your customers. The disaster recovery plans don't need to be tested or can't be tested. I would find every way to challenge that. And even if that means setting up a whole isolated sandbox just so you can test things out, it is worth your time and effort to do that. All Azure services are always available. I wish that was true, but it's not. In fact, no cloud can offer all of their services to be always available. Also, those who need to know, and you told your boss, so they told their boss. And those go together on a base. That came from a situation that I dealt with many years ago, a couple of decades ago, on a outage that I was dealing with, and I had assumed that because I told my boss of what was going on, that they told their bosses, etc., and that was not the case, and it turned into quite the nightmare. And also, there is no such thing as infinite scaling. Do not rely on that. So that kind of goes along with the resource capacity um, uh, assumption there. And the backups are good. No, there's is happened more than once to other people that they've got their backups and they verified that their backups are actually occurring. The problem was is when they went to actually restore from a backup, their backups were empty. They did not verify and validate the data on the backup could actually be retrieved and was actually valid. And yeah, like the meta problem, the assumption was with the DNS issues that people could always get into the server room. So how should we plan this? Let's talk about a high level approach of planning some resiliency. So if you were to ask me and you want to bring me onto your team as a contractor and you say, hey, I want to look at building out some resiliency and kind of prepare to minimize some of our disaster recovery efforts, what would we do? First thing I'm going to do is analyze and understand what you have. I want to understand the architecture. I want to understand every little piece and what kind of replication things are in place there. I'm going to look and evaluate the criticality of each of the items of your architecture, of all of the applications that you have in productions. Which ones are ranked as most critical to not as critical, so that we can focus on the ones that during a disaster recovery time period, what depending on the outage as well, which ones need the most focus first, as well as going to order of importance, grouping the resources per business need. What I kind of give an example is maybe processing payments before scheduling new ones, right? Is maybe that's an order of importance from one business understanding versus another. And being able to evaluate ability to replicate. Some of the when you do replicate your secondary region, you might have to make configuration changes before things can be brought back online. Also, no, when you want to replicate over to or build out your secondary into another region, you got to see if not only about the capacity issues, but as well the product availability. For example, if you're running MySQL on a VM, but that version of MySQL is actually already out of date and it's out of end of life, by the ability to spin up another one in a disaster recovery time period would be the wrong time to find out that you're unable to do so. Also, the target region, the network, it's going to have a different IP address range. If you are going to peer them or a VPN connection, then they cannot overlap. So you want to make sure that they are definitely different. Okay, so I have spewed out a lot of information about Azure Resiliency, gone over both RPO, RTO, kind of the difference between resiliency versus disaster recovery. Resiliency is trying to minimize, planning ahead to minimize that disaster recovery efforts should and when they become necessary. And other than that, do you guys have any other questions that I can tackle?
I had a
And
question. Did I hear you say something about a tool that would help you with the policy part? My thing hiccuped and
oh, yeah, so Azure Policy, and there is and I'll see if I can find a link on Azure Policies. So an Azure Policy is a way to guarantee, well, I say guarantee, it's a way to help um, verify. For example, I have used it to help make sure that in a development environment that I cannot spin up the most expensive Azure plan, Azure service plan. No sense spending $200 a month when the free one would do. So things like that, you can also use it. Say, I use an Azure policy to make sure that no resources are spun up outside the United States because there was no need for it in the development environment, right? Whereas in production, maybe you have another change on that where the policy is going to say that you can only create resources in the UK and maybe India, but not any of the other regions, etc. So you can use Azure policies to help maintain and govern things like that, even to enforce, do you have tags, which I highly recommend. Put tags on your resources, things like, is this meant for production? Is this meant for test or development? Who created this? So that if anybody comes up behind, afterwards and it's like, well, who created this? Are they still using it? You'll know a point of contact. Even to virtual machines, to app services, etc. Put a tag on there that was like a project name that says why, what project is this resource being used with? Because in the cost analysis report, you can look at that by tag. And so go down to like a project and know what your cost is on that application versus another application, etc. So you can use Azure policies to enforce a lot of various things. There's a ton of stuff you can do with Azure policies. And like I said, you can create it after the fact, and then it will list which ones are not compliant. And so that you can go back and fix those. Uh, yes, exactly, Randy. You can evaluate the resources against the policy to find out the resources that did not meet the policy. Absolutely, it's called the compliance, and it is very useful. So like I said, in a development environment, you may want to restrict it so nobody can go to a very expensive version of something. Whereas in production, you may say you're not allowed to use something that's free because it doesn't have all the required options that a standard or a premium option would have based on that. So yeah, Azure policy, definitely a good thing to look into. Any other questions? I know I went over some stuff really, really fast. But if there's anything you want me to go over, let me know.
Is I have a question. Do you happen to
Yeah.
know, so is there a process? Because if one region goes down and you go to another region, and then basically, let's say 50% of the people have the same problem you have, if you have an application, is there a strategy for maybe creating an application that is heavy in your main region? It can do everything.
Mhm.
And then, like you were saying with the gambling, you reserve the second region maybe for a lighter response to what the application should be able to do. Does that make sense? Or is that not?
Yeah, so something like that, I probably wouldn't do it at the application level because generally applications won't know that there's an outage. They just run where they can. But you might have, say, for example, in your production and or say in your primary region, if you're scaled so that you're as performant as possible, you're handling, say, 1,000 orders a minute, something like that, right? It's a great problem to have. Or you're scaled up really high. Something happens, now you're in your secondary, but your best you're going to get is maybe 400 a minute and not your 1,000, which means other people are going to feel the pain. Other customers are going to feel the pain on that. They're going to have either they can't make orders or maybe it's an API that's going to have you're throwing some 429 error codes that says I need you to retry, come back later, right? Where you might have to be in that position as long as you can, where you're tolerating a lower performance in lieu of getting other resources because you're competing with others, and then until your primary region comes back online. So definitely on something like that, and this is where I go back to that evaluating what would I do if I'm going to analyze and understand your current what you currently have. I'm going to evaluate the criticality of each of those items, and that's exactly what I'm going to do is go what if you've offer say 10 services, is there three that you can just have zero that is just not available in lieu of the other ones that are higher priority? Those are the kind of challenging questions that I would bring up to any client and go, you're the better judge of that, but that's a question that's going to have to be asked and dealt with.
Got it. Thanks.
Mhm. Yeah, good question. I appreciate it. Any others? All right, I will go ahead and I can get to it. I'll go ahead and stop the recording.